Consider this example. Draw PQ equals 10 centimeters and then construct a perpendicular to PQ at P. Shall we start the construction? Here we are. Draw a sufficiently long thin line, then mark a point P to the left on this line. Mark another point Q at a distance of 10 centimeters from P on this line using compass. Join P and Q with a thick line. Then with the P as center and with some convenient radius, draw sufficiently long arc intersecting PQ at R. Now with the same radius, don't you change the radius please. With the same radius, taking R as center, draw another arc intersecting the previously drawn arc at S. Again with the same radius, taking S as center, draw another arc which intersects the longer arc at T. Now in the next step you are allowed to change the radius, but the radius must be more than half the length ST. Take some radius and keeping it the same for both the arcs, draw two arcs with the centers S and T. Let the arcs intersect at point M. Join PM and produce it upward. Let the end point of this line be M. Now measure the angle NPQ. It is 90 degrees. It is a right angle. So NP is the perpendicular drawn at P to PQ. It's quite easy, isn't it? For practice, let us have one more go at this. Let J be any point other than P and Q on PQ. That's point J. Let us draw a perpendicular at J to PQ. I am going fast with these steps. Don't change the radius there. Again, don't change the radius. Now you can change the radius, but you should keep it the same for both the arcs. Let the arcs intersect at some point. Mark the point. Join this point with J and produce it. You may want to measure the angle, one of the angles at J. It will be and it must be a right angle. Now, what is the geometrical theory behind this construction? Let us explore it now. We need the figure. Let us borrow it from the construction page. Here it is. In this figure, we need to prove that NP is perpendicular to PQ. That is, angle NPQ equals 90 degrees. To do that, we should do some extra constructions. Join RS, then ST, then PS and PT. Here we have used the same radius to locate points R, S and T. So all these sides PR, then RS, PS and PT and then ST, all are equal to one another. Consider this triangle. Here we have all the three sides equal, so it is an equilateral triangle. PRS is an equilateral triangle. We know that measure of each angle in an equilateral triangle is 60 degrees. So angle SPR, this angle is 60 degrees. Each of the angles is 60 degrees, but for our purpose we need this angle. Again, consider this triangle. It is also an equilateral triangle and angle SPT equals 60 degrees. Now, consider this angle SPT. Here we have an arc from S to T, and also we have drawn two arcs with equal radii with centers S and T to mark M. Then we have joined PM. Does this remind you any of the constructions we studied before? Yes, of course. We have constructed a bisector to the angle SPT. Therefore, PM or PN is the bisector of angle SPT. Therefore, each of these angles, angle SPN and then angle NPS, each of them is half times 60 degrees, that is 30 degrees. This is 30 and this is also 30. Angle NPS equals 30 degrees. This is the angle we need here. Now, consider angle NPR or MPR. It is the sum of, consider this angle. This is the sum of this angle and this angle, isn't it? Angle NPR equals angle NPS plus angle SPR. We have already proved that angle NPS is 30 degrees, then angle SPR is 60 degrees. Let us plug in the values. Angle NPR equals 30 degrees plus 60 degrees, which gives us angle NPR equals 90 degrees. This is what we needed to prove. NP is perpendicular to PQ. Therefore, NP is the perpendicular drawn to PQ at P. Hence, the justification. It's quite easy. Don't you think so? That's it for now. Keep watching my videos. Bye.